All right, here now we're going to have what I call the tail of two Lewis structures. We're going to have ozone, which is O3, and it's a molecule, and then we're going to have Br3. I'll put square brackets around this. The whole Br3 has a -1 charge to it. We're going to go through and we're going to assign the Lewis structures and do the formal charges. And I want to do a comparison here at the very end as we get through this. Okay, so 6 plus 6 plus 6. 6 valence electrons from each oxygen gives me a total of 18. Okay, this is the first part that's a little bit weird. So you're used to something have a central atom and then having atoms on the outside. It just so happens in this case the central atom and the outside atoms are the same element. And so that's okay. We used up 4 electrons to form the 2 bonds, so we're left now with 14 electrons. Go ahead and satisfy the outer atoms first. 2, 4, 6, 8, 10, and 12. Okay, I used 12 electrons to satisfy the outer atoms. 12. And that leaves me with 2 electrons left over without even thinking about it. Any extra electrons at this step go onto the central atom. But now we're not done. In the other cases, we were done at this stage. We actually, if we look now, we still have a little bit of work to do. And so I look at this structure, and the outside oxygens are fine. They have 8 electrons around them. But this oxygen in the middle has 2, 4, 6 electrons, and it also needs to have 8. So what can happen here is I could do this with the left oxygen or the right oxygen. I'll take the left one here, and I will remove the lone pair and use that pair of electrons to form a second bond between the left oxygen and the middle oxygen. Okay, now if I check, everybody's happy. So the left oxygen sees 1, 2, 3, 4, 5, 6, 7, 8 electrons. The middle oxygen sees 2, 4, 6, 8 electrons. And the one on the far right-hand side sees 2, 4, 6, 8 electrons. And so this structure is, we've satisfied the octet rule, and we've assigned all 18 of the electrons. Now, I'll redraw our structure, and we can do formal charges. Okay, so there is our structure just redrawn, and you'll remember again, for formal charges, I want to go in and cut up the structure with boxes instead of circles. Boxes to remind me that I'm breaking the bonds when the edge of the box crosses the bonds. And so this oxygen right here, it has 1, 2, 3, 4, 5, 6 electrons. An oxygen atom has 6 electrons. And so the left one here has no charge. The right one, however, has 1, 2, 3, 4, 5, 6, 7. Okay, and an oxygen atom again should have 6. It has an excess of negative charge, and so this oxygen atom has a -1 charge. And then finally, the oxygen atom there in the middle, in the Lewis structure, has 1, 2, 3, 4, 5 electrons, and again it should have 6 on the periodic table. So this has a +1 charge. +1, -1, and 0. Well, just like when we looked at some of the other ones, 0 plus 1 minus 1 is equal to 0. And so the charge on this has to be 0 because the formula is O3 without any charge indicated. All right, let's hop over and look at tribromide now. So each one of the bromines brings 7 electrons. It's the 7th column of the periodic table. And the interesting thing here is the negative charge, it adds an electron. Okay, a negative charge adds an electron to the electron count. And so I have 22 total electrons to assign. But part of this is going to look familiar. So Br dash Br dash Br. Again, we have this weird scenario where the central atom and the outer atoms are the same element. But in other ways, it's a lot similar to things that we've looked at before. And doing that again required 4 electrons, leaving me with 18 electrons to assign. I go to the outer atoms, 2, 4, 6, 8, 10, 12. That leaves me with 6 electrons to assign. The outer atoms are happy. Any extra electrons at this point, without even thinking about it, get dropped onto the central atom. Okay, and now I've used all my valence electrons. This is strange, but okay. So the leftmost bromine here has 8 electrons, 2, 4, 6, 8. The right one is the same, 2, 4, 6, 8. The middle one, however, has 2, 4, 6, 8, 10. And that's okay. So any element that's past the aluminum on is a heavy element, and if it has to, it can have 8, 10, or 12 valence electrons around it in the structure. I want to be good here and put my brackets around and remind myself that the whole this whole beast has a -1 charge to it. So the main thing that I want to have both these together for you guys to look at is to show you that these double bonds or triple bonds that you can form in a molecule only occur when you get to a situation where you've assigned all the electrons and you have the middle atom is still unsatisfied. So here, I do not take and make double bonds or something like that between the bromines, because when I have extra electrons, they appear as lone pairs on the central atom. When I have a shortage of electrons, that's the only time that I form double bonds or triple bonds. Right, I'll rewrite my molecular ion down here, and we can go about assigning our charges. Okay, so I'm going to again cut it up with boxes. And the left bromine that I have here in the Lewis structure, it has 1, 2, 3, 4, 5, 6, 6. It has 7 electrons in the Lewis structure, and bromine should have 7 electrons as an element. And so this bromine has no charge. That one is its identical twin, so it also has no charge. I bet you can figure this one out before I do the calculation, but we'll do it anyway. This bromine here in the middle has 1, 2, 3, 4, 5, 6, 7, 8 electrons in this structure. From the periodic table, we expect it to have 7. This has an excess of electrons, and so there's a -1 charge on the central atom. And so the total charge 0 minus 1 plus 0 is equal to -1. Okay, so summing up the charges on each atom has to give me the charge of the anion, if it's an anion,